Hello and welcome to a short talk in which I want to tell you about a method to treat the issue of strong coupling in non-Markovian thermodynamics. The starting point is, as usual, a microscopic system bar Hamiltonian, which I write in the following form. So this describes a system S where this Hamiltonian, which might be driven somehow, so time dependent, and this is coupled to one or two or several heat reservoirs where some interaction Hamiltonian, the bar Hamiltonian, and the reservoirs are described by some temperature and maybe also some chemical potential, but for the moment that's fine. And then whenever this system is only weakly coupled to macroscopic, memoryless reservoirs, it is well known how to derive the standard laws of non-equilibrium thermodynamics. Namely, the first law tells you that the change in system energy is balanced by the heat flowing to the system and the work done on the system. And the second law tells you that there's an entropy production rate, which I can write as follows. That's the time derivative of the entropy of the system plus the entropy produced in the reservoirs, and this is always positive. Now, if you violate one of the assumptions, so if basically the system is coupled strongly to maybe even non-Markovian reservoirs, then at the moment there's no accepted standard framework how to derive these kind of laws. There are a few proposals, but usually they only work for specific situations. And here I'm proposing a new idea how to tackle this. So suppose that you are able to somehow identify subdegrees of freedom in the reservoirs, which I shade here in this way. And these degrees of freedom are supposed to be responsible for the strong coupling phenomena and non-Markovian behavior. So given that you're able to identify these degrees of freedom, then it's basically known from what I've said before that this kind of new supersystem S prime obeys these laws of thermodynamics. So basically I can derive for the new supersystem these laws. So I basically put a prime on all the quantities here, and I know that this is right. And this is actually indeed the idea I'm proposing. So what I say is, in this kind of strong coupling and non-Markovian regime, one should actually rethink the notion from a thermodynamic point of view what the system is. And once I have found this right system environment partition, then the big advantage is, of course, that one can carry over all the framework and all the structure from quantum or stochastic or non-equilibrium thermodynamics to this redefined frame. And a particular method how to find these degrees of freedom in the reservoir is presented in the paper, as well as two examples where I apply this framework. Thank you very much, and that's all.